Section 3.1, example 6, finding the area of a region. So find the area of the region bounded above by the graph of y is equal to tan inverse of x, and below by the x-axis over the interval from 0 to 1. So bounded above by that function and below by the x-axis, we just have to integrate this function over the interval from 0 to 1. So we're looking from 0 to 1. Tangent inverse of x dx. So I know this feels weird, but let u equal to tangent inverse of x, and dv is going to be equal to dx. So one thing we could do is, so we could use our trig substitutions or do this a long way. We could just use our trig substitutions, our trig identity substitutions. Inverse trig, I think that's what they're called, inverse trig substitutions. So the derivative du is going to be equal to 1 over x squared plus 1 dx. And over here, v is going to be equal to x. So here, 0 to 1, tangent inverse of x dx is equal to u times v, tangent inverse of x times x. We can write that backwards. X and minus the integral of v du. So v du is going to be still x squared plus 1. In the numerator, we have x dx. We're integrating from 0 to 1. And now this is something that we could just integrate naturally. X times tangent inverse of x. Here we could let u equal to x squared plus 1. Du is equal to 2x dx. So we have minus 1 over 2 integral from 0 to 1. Or we could plug these values in. No, we'll switch it all back. So we just have to make sure that we switch it back at the end, because these are being integrated over the 0 to 1, not the integrations here. So we would have u to the negative 1 du, x times tangent inverse of x minus 1 over 2 ln of u evaluated from 0 to 1. Let's substitute u back in. One over 2 ln of u happens to be x squared plus 1, and we're evaluating from 0 to 1. So now the whole thing is being evaluated from 0 to 1. So this is going to be first evaluating at 1. We have 1 times tangent inverse of 1 minus 1 over 2 ln of 1 squared plus 1. And there's that, and we're subtracting evaluating at 0. So 0 times tangent inverse of 0 minus 1 over 2 ln of 0 squared plus 1. And tangent inverse of 1. So where are they both equal to 1? Where are cosine and sine both equal to 1? On its interval, it's just going to be pi over 4. And we have a negative 1 over 2. We have 1 squared plus 1, that's 2. So we have 1 over 2 ln of 2. This part goes to 0 because it's being multiplied by 0 here. And then we have ln of 1, which ends up being 0. We raised e to a power in order to get 1. We raised e to 0 in order to get 1. So these two end up going to 0. So this here is our solution. Simple as that. There you go. If you have any questions whatsoever, please feel free to ask. Otherwise, bye.